Hello and welcome my dear students. Now we have reached the last part of our chapter, chemical reactions and equations. Hope you are very clear with all the chemical reactions that we discussed. Now we will discuss about the rate of chemical reaction. Some reactions occur at a faster rate whereas some reactions takes long time. For example, the recent topic that we did, corrosion. Corrosion will not happen in one day. Corrosion is a slow process. So corrosion is a reaction in which the rate of chemical reaction is very low. It takes place at a low speed. Okay. The reaction is a slow reaction, corrosion. Same way, erosion of soil is also a slow reaction. Some reactions happen fast. That is the reaction that we have learned. Now you have to tell in your mind which type of reaction is this. The reaction between sodium sulfate, Na2SO4 plus barium chloride gives NaCl plus barium sulfate. Now this, as soon as you add sodium sulfate to barium chloride, in fraction of seconds you will see that a white precipitate is formed, that is of barium sulfate and NaCl. So this reaction takes place at a faster rate. So this is a fast reaction. Okay. So rate of reaction depends upon certain factors. Hope you have told the type of reaction in your mind. This is a double displacement reaction, also called as precipitation reaction. Sodium sulfate and barium chloride. Okay. So today we will learn about the factors affecting rate of chemical reaction. Lot of slow reactions as well as fast reactions. Few examples are discussed in your textbook. Go through it. Like fermentation. Fermentation will also not happen in quickly. You will have to keep it overnight so that the dough or the batter gets fermented. Again, some things which can increase the rate of reaction. What are they called? There are certain conditions where the rate of reaction can be increased. We will talk about all these factors which are affecting the rate of chemical reaction. The first factor affecting the rate of reaction is nature of reactants. We have studied the nature of reactants, the elements which are most reactive. I hope you remember Kanaka. Remember? Kanaka, Mazaf, Priyanka Chopra, HG, AG, AU, PT. So this series I had given you. So rate of reaction depends upon the reactants. You are making sodium react with suppose an acid and now let me complete it. This will be magnesium, this is aluminium, this is zinc, this is iron, this is lead, this is copper. No? So if you are making magnesium and zinc react with an acid, rate of reaction will be more, or the reaction will happen faster when magnesium reacts with an acid compared to zinc reacting with an acid, because magnesium is more reactive than zinc. So let us take an example where you have hydrochloric acid and we are making aluminium to react with HCl. Al plus HCl gives, we will get a salt, AlCl3 plus H2 gas is evolved. Okay, this is the first reaction. Now I will make, in place of aluminium, I will take another reactant. Zn plus HCl gives ZnCl2 plus H2. So HCl is same. In one test tube, if you take Zn plus HCl, in the other test tube you take Al plus HCl, the rate of reaction, that is hydrogen gas, is seen coming up fast. First, hydrogen gas is seen coming up first from, which is more reactive here, aluminium or zinc? Please check the table. Aluminium is coming before zinc. So the hydrogen gas will be evolved first from test tube number or beaker number 2. Okay. So why did hydrogen gas evolve first from the second test tube? Because aluminium is more reactive than zinc. So hydrogen gas was evolved at a faster rate than the reaction which happened when zinc reacted with HCl. So did you understand? The rate of reaction depends upon nature of reactants. Some metals are more reactive. So the reaction also happens at a faster rate. Hope you are clear with the equation. Now we have to balance it. Please balance. Aluminium 1, 1. Chlorine here 1 and here 3. So we'll try to put a 3 here. But now hydrogen is 3 here whereas hydrogen is 2. So here we will put a 3, 6, no? So we will put a 6 here. Okay. When we put a 3 here, hydrogen becomes 6. So I will put a 6 here. Hydrogen here 6. Now chlorine is 6 whereas here only 3. So I will put a 2 here. 2 3s are 6. And for aluminium also I will put a 2. It is balanced. Same way, balance this reaction. Zinc, HCl2. Now it is balanced. Okay. So the second factor affecting the rate of chemical reaction is size of the reactant. Size of reactant. These all things I need not explain. We have experienced it that while making lime juice, if you add sugar, it will take some time for the sugar to dissolve. But at the same time, if you powder the sugar and if you add it, okay, you will get lime juice getting ready more faster than using crystals of sugar. Same example you can apply here, but let us keep the standard little high. We'll not talk about lime juice. We'll talk about Chabat tile reacting with HCl. If you take pieces of tile reacting with HCl, at the same time, if you make the powdered tile react with HCl, you will see that the carbon dioxide gas evolved will be at a faster rate, or the reaction will be faster in the second reaction where you have used powdered Chabat tile. Carbon dioxide gas, that is the effervescence, will be seen, bubbling, will be seen faster with powder than the piece of tile or than the bigger particles. Smaller the size of the reactant, faster will be the rate of reaction. Just remember it. Smaller the size of the reactant, faster will be the rate of reaction. So with the Chabat tile piece, reaction will be slow, whereas with the powder, effervescence will be seen. Effervescence is nothing but carbon dioxide gas, will be seen faster with powder. Okay. The third factor affecting the rate of chemical reaction is again now concentration of the reactant. Concentration of reactant means if you are using dilute HCl and you are using concentrated HCl, the reaction will be faster when you use concentrated HCl compared to dilute HCl. For concentration of the reactants, you can write this example. Let us consider calcium carbonate CaCO3 plus HCl. In the first case, when dilute HCl is used, you don't see much difference, but there is reaction happening. But at the same time, if you use concentrated HCl, you will see that there is lot of effervescence produced and the reaction is somewhat like this. I want you to copy it down in your book. Calcium chloride plus effervescence is always because of carbon dioxide gas and there are water molecules. So when you use concentrated HCl, we will see that the calcium carbonate disappears. Calcium carbonate disappears because all calcium carbonate is getting converted into calcium chloride with effervescence. Whereas if you use dilute HCl, the rate of reaction is very slow. It's a slow reaction. With concentrated, it is a fast reaction. You have to write this reaction also. Okay, moderator will be impressed if you write this reaction. It is not given in the textbook, but you copy the reaction. See the reaction, CaCl2 plus CO2 plus H2O. Now let us balance it. Calcium, calcium done. This is 2. So we'll put a 2 here. Now carbon 1. Oxygen here 3. Here 2 plus 1. 3. Oxygen balanced. Carbon balanced. Hydrogen and chlorine also balanced. Okay. So it is a balanced reaction. Okay. Factor affecting the rate of reaction is temperature of the reactant. Temperature of the reactant. Again, temperature always increases the rate of reaction. Formation of curd example. Formation of curd happens faster during summer season, whereas the formation of curd is a slow process during winter season. So that example you can give for temperature of the reactant. Let us talk about the last and very important factor, that is catalyst. Again, we have discussed about catalyst in our previous classes. Example here is potassium chlorate, KClO3. Even when you heat it or you use powdered potassium chlorate, the rate of reaction does not increase. Even when you, after heating potassium chlorate or using potassium chlorate in powdered form, the rate of reaction does not increase. So what is that special ingredient which makes the rate of reaction faster is the catalyst, that is manganese dioxide, MnO2. The moment manganese dioxide is used as catalyst, you will see that it decomposes into KCl plus oxygen gas. Okay, so here what is that is making the rate of reaction happen faster is the use of this catalyst. And as we all know, catalyst is a substance which speeds up the rate of chemical reaction without itself undergoing any chemical change. So that is a catalyst. Another example also we had discussed, wherein we had used hydrogen peroxide, H2O2, and it decomposes into H2O plus O2 gas. We had also discussed this reaction. Hydrogen peroxide decomposes into water and oxygen gas. This is a slow process and it also speeds up after adding the catalyst MnO2. So two examples you have for catalyst. So to make a note of this, see whether it is balanced. KCl. Here 3 and here 2. So we'll put a 2 here. So this will become 6. We'll put a 3 here. 6 oxygen. Now we'll have to put a 2 for KCl. This is also balanced. Here we have oxygen 2. Here we have oxygen 3. So we will try to put a 2 here. So now this became 4. We'll put a 2 here. 2 plus 2, 4. Now it is balanced. 4 and 4. 4 and 4. So in this way we have discussed 5 factors which affects the rate of chemical reaction. It can be asked as a paragraph based question. Kindly go through it with examples. You have to write examples. Given much time on this chapter, chemical reactions and equations. See to it that all chemical reactions and equations are handy with you anytime asked, you are okay with the chemical reactions. Okay, now for a new day, we will start with the next chapter in the coming days. Till then, be thorough with the chapters covered. Take care. Bye, students.